Hi, in this video we're going to review some of the questions from the homework. First one up is from the pure paper, question 13, which is the equation kx squared plus 4kx plus 3 equals 0. It has no real roots. Find the set of possible values of k. This kind of question should get you thinking about using the discriminant, and with the discriminant we know that d is equal to b squared minus 4ac. And because it has no real roots, b squared minus 4ac, the discriminant must be less than 0. Okay, so we're looking at b being 4k squared, minus then 4 times a. The a value in this case is the coefficient of the x squareds, and 3 is the c value. So expanding that, I get 16 k squared minus 4 times 3, which is 12 k, has to be less than 0. And then this will factorize, giving me 4k, if I select the pen, 4k brackets 4k minus 3 has to be less than 0. This is a quadratic, and for any quadratic we need to be aware that there are more than one solution, and in a quadratic inequality we're looking for the areas here where the graph goes below 0. So from here and here, if we find those critical values marked with x's, if we find those, we want the area in between them where it's below 0. Okay, so solving that, I can see that 4k, if it equaled 0, that would give me 4k equals 0, therefore k equals 0, and also we can have 4k minus 3 equals 0, so k equals 3/4. So the values here are 0 and 3/4, and we want the area, the bit where k is between 0 and 3/4. So 0 is less than k is less than 3/4. Now it's a good idea to refer back to the original question. We can see that if k equals 3/4 we get a lovely quadratic equation, but if k equals 0, it's not a quadratic. We get the answer 3 equals 0, which can't exist, has no real solutions, so k can equal 0 in this example. Very important to always double check. Okay, let me know if that was all clear or if there are any things that need reviewing. Thank you.